Am I the only one who cannot hear Roy?
Yes.
Okay, so we cannot both we cannot hear you. We still cannot hear you. All right, so I thought I was the only one.
Yeah.
Oh, are you able to hear me now?
Yeah, now it's good.
Okay, that is really weird because I changed nothing. I refreshed screen. So sorry, I hope people joining us for this seminar are too confused now. As I was saying before, you couldn't hear me. So today's panel is about serverless and service mesh, and especially what's next. With me, I have Abdel, who's working as a senior cloud developer advocate at Google, and I also have Martin, who's working as a service mesh team leader at Allegra. Abdel, could you introduce yourself a bit more and tell us about your experience with serverless and service mesh?
Yeah, sure. Hi, everyone. I am Abdel. So I've been at Google for 9 years now. I started in the data center back in Belgium, and then I moved to professional services, which is the internal consulting part of cloud, where I spent about 4 years actually working with customers on architecting cloud applications around Kubernetes, GKE specifically, and service mesh with Istio most of the time. So I worked with all sizes of companies, small banks, big banks, etc. And I was also a technical reviewer on one of the first books that have been written about a serverless platform at Google we call Cloud Run. There was a session about it yesterday, actually, in the conference. So I did also some work around Cloud Run, and now I am a developer advocate around the topics of service mesh, Kubernetes, and serverless.
Nice, really cool. Could you introduce yourself a bit more, Martin?
Yeah. So hi, my name is Martin. I'm working at Allegro currently, and I'm leading the team that is responsible for service-to-service communication in Allegro. The main product that we are creating is the control plane for Envoy. We don't use Istio because when our project started, the service mesh world was pretty small and there was no much of control planes available. And since we were on the Mesos Marathon and was using VMs, the team at the time decided that we should build our own control plane. And beside of this, we are working on our microservice SDK, which is written in Java and with Spring. And basically, that's all from me.
Okay, great. Thank you. So I've prepared a set of questions we will be handling today. But if you have any other questions coming from the audience, feel free to use the chat for this. And I will monitor this. So in case you have a question that is urgent, I will immediately. If you have another question that is not directly related to this set of questions or the answers, use them in the chat as well. And then we will be using the end of this session to answer those questions for you. So something I'm always thinking in this area of of serverless and service mesh, CI/CDs, and a more DevOps kind of way of working. My first question to you, Abdel, is when was the last time you SSH'd into a server?
Oh, well, I'm probably an exception just yesterday because at Google we have your workstation that you use to write and compile code is not your laptop, right? Laptops are considered untrusted devices. So in order to do anything with code, you have to SSH into a remote workstation. So that was yesterday. But that was my workstation. So SSH into production have been a while, maybe a year or more.
Yeah, that's even quite recent.
Yeah, just because of the nature of how we work at Google, but that's probably not the same. That I cannot clone code on my laptop. That's just not something Google allows us to do.
Yeah, interesting. I can imagine that at every company it's different, and a lot of companies I know actually don't allow you to SSH into a server.
Probably, yeah.
How about you, Martin? Are you allowed to SSH into your servers?
Yeah, actually I am. And the last time I was using SSH to connect to machine was yesterday, and this is because I work in technical platform in Allegro, and we are working on service discovery in Allegro, and we are maintaining console. So I had to do some routine maintenance task, but for the rest, or maybe most of the developers in Allegro, they don't have the permissions to SSH into the machines and do stuff there. So it's all hidden behind some common interface, and all you need to do is to push the button and deploy it to some environment.
Yeah, I can imagine. How do you make the decision which developers are allowed to SSH into a server or which aren't? So I can imagine if something goes wrong, then someone should be responsible.
Yeah, so it's mostly the technical platform teams that are operating on those environments. For example, the team that is working on Kubernetes, they have all the permissions they need. Since we are working on service discovery on service mesh, we can SSH into some machines, not all of them, that are needed for our day-to-day work, but the rest of them is closed for us and for the rest of the developers.
Okay, well, sounds like a good chain of responsibility. So before we deep dive more into the technical details of serverless and service mesh, I was wondering what is the technical level of the audience currently listening in. So just to be fully sure that everyone understands what the serverless when we're talking about serverless, or what is a service mesh when we talk about a service mesh. Does one of you want to give some more explanations about these definitions?
Maybe I can take serverless and I'll let Marcin explain what a service mesh is. So serverless is actually a term that is like kind of generic. It doesn't really mean a specific technology. It's more like a model of how would you as a developer consume cloud services. So the idea of serverless is that you would use a platform to deploy your app, which abstracts the infrastructure layer for you, so you don't have to see it or you don't even care about it. So in a serverless world, basically you write your code, you build your code locally, you verify that your code works, and then you either put it in a container or use a command line tool by some cloud provider to upload your code to the cloud provider environment. And then the cloud provider will return to you an URL with ideally an SSL certificate and all the security stuff around it that you will use to invoke your code, right? Um, and then maybe if we want to go even further, um, like that application or that piece of code would scale in and out automatically according to the demand. Maybe the cloud provider will expose certain features, certain knobs you can turn on and off to kind of adjust how your application scale up and down. But you don't have to worry or care about what server it's running on, where is it. There is still a server there. It's not entirely serverless. It's just that it's not exposed to you. That's kind of the concept of serverless on a high level.
Great explanation. I always feel people struggle with the definition because there's so much, as you said, it's some sort of a, I would say a container word, but that is even more confusing. But it's quite generic indeed. Okay, thanks. And Martin, could you tell us a bit more about what a service mesh is?
So I don't think I have such a pretty definition for service mesh. Maybe I will tell for what it does from my perspective. So in the previous world, before the service mesh, when we were operating using microservices, there were a lot of services, a lot of technologies. Some teams were writing code in Java, some in Python, and other languages. And there are many common things in those services, especially when it comes to specify timeouts. You need to retry on failing requests. You can use some circuit breaking policies. You have to secure somehow this connection. And previously we had to implement all of this stuff inside of the services. So each language has to have its own implementation of those stuff. And thanks to service mesh, we are able to move this logic from the service to the infrastructure world. And in order to do that, the services are no longer communicating with other services. They are communicating with the proxy that is deployed alongside with the service. And the proxy deals with all the stuff that I mentioned previously.
Okay, great. Thanks for your definition. So I hope everyone in the audience now is fully aware of the topics we will be discussing, if you weren't already, of course. Something I often see with companies is they start building the architecture with serverless because it's an easy way to get started, and going cloud native or having a service mesh is something it's a bit more complex, and I think it also takes a different approach from a team. Does any of you see companies migrate, going from serverless to service mesh later on?
I personally have seen probably the other way around, which is companies starting with Kubernetes and service mesh, because I mean, service mesh works for VMs, but it's mostly a Kubernetes concept, right? It's like if you look at something like Istio, it was designed actually to run on Kubernetes initially. You could still include VMs in your mesh, but it's primarily for Kubernetes. So I've seen companies starting with Kubernetes and service mesh, and then later on moving maybe not all their services, but some of their services toward a serverless platform. On GCP, that would be something like Cloud Run, where you just bring a container and then we run it for you. Or maybe to something like a serverless function, if that's more adapted. Because if you, like moving a function to a service, if it's sort of independent from your core application and that function then only execute like a single sort of business transformation or like data transformation or something, if you move it to a function, it's much better because like one of the downsides of service mesh is that hefty tax you have to pay because of the proxy. Because every single request going to the service have to go through a proxy, which has to process it first before handing it off to the service. And this actually could be sometimes problematic for some microservices that are supposed to be fast. They don't process a lot of data, but they don't process big amounts of data, but they just process a lot of it, right? I'm trying to think, for example, like a microservice that process card payments for a e-commerce website, right? While processing a card payment is not like the amount of data in each call is not gonna big, but you're gonna process a lot of them per second if you have a very popular website, right? Let's say Amazon, or like if you're selling the FIFA World Cup tickets, right? So this is probably a service that is more adapted for a function as a service function, than for a service mesh, right? Or something similar. So I've seen customers sometimes starting with Kubernetes and service mesh, and then realizing later that, okay, for certain things, we don't really need a service mesh. We can move them to a serverless platform because it's much faster, much cheaper, etc., etc.
Yeah, that makes sense. Makes sense. The things I'm hearing from companies is they want more control, and that's why they will go for service mesh later on instead of working serverless. Okay, Martin, did you what were you running before you had adopted a service mesh at Allegro?
Yeah, so the most of our services were running on Mesos Kubernetes, on Mesos and Marathon before the introduction of service mesh, and some of them were on VMs. So in Allegro, the first step was VMs, and we were running everything in VMs. Later on, the Mesos Marathon came, and this was nice improvement for our developers. And then later on, we decided that we need service mesh. And as I remember, the most important reason for service mesh was secure connections, which our security team really wanted. And then came the rest of the service mesh improvements. And actually, as for the serverless and the classic serverless like Lambdas, we are experimenting with it right now. And our micro front-end framework that we are running up a box is using actually our OpenFaaS that is deployed in our on-premise data centers for this. So actually, for some workloads, we are transitioning into the serverless and the Lambda world. But the way that the platform, the technical platform is created in Allegro makes it, for me, it makes it serverless for the users, because in Allegro, you only specify how your app should be run, how to start actually the process, or you give us the container, and we deal with all of the rest of the things. You don't need to specify where it will be run. If it's Mesos Kubernetes, you don't need to care about it. How many resources do you need? Of course, you can specify all those things, and if you need fine tuning, you can do that. But if you want to prototype something and quickly deploy it to production, you don't have to worry about all of the infrastructure. Simply write your code. Build a package or container and deploy it. So for me, it's some kind of serverless, but it's not like the thing that most people are familiar with, which are lambdas.
Okay, interesting. So what kind of how are you deciding if you want to go server or with a service or adopt it into your service mesh?
In Allegro, or
Yeah, so you described you are also exploring serverless, or maybe go serverless with some of your functions.
Yeah, there was specific case for the serverless, which I'm not familiar, and I'm not comfortable talking about, simply because I don't have all the details. But in Allegro, most of the services are running not as lambdas, and there are really few lambdas. And I think that maybe the teams closer to big data and to the teams that simply need to transform some data that they use, and not a lot of data, they use lambdas.
Okay.
Yeah, I think
We
that the
don't have much
decision.
business logic in lambdas.
I think that the decision depend on many things, right? Marcin talked about security, which is actually a very important decision when you adopt service mesh, because one of the things that service mesh gives you is this authentication and authorization out of the box, right? So auth N and auth Z. So you could drop in Envoy or a proxy sidecar to do MTLS, for example, between services. That's what we typically refer to as zero trust model, right? And then you can add to that the fact that you can do authorization between services, right? Most of the people that probably listen to us are familiar. When I say authorization, are familiar. When I say authentication, are familiar with JOT tokens, where you just have a user coming into your system. You verify the JOT token and you verify the identity of the user. But in a zero trust model architecture, you want also to have authentication between services, right? And the idea here is that if somebody managed to uh, find a way into your system, they can just hack one service, but they cannot like literally transfer themselves across services because they will require authentication. So this is something that the service mesh gives you out of the box by basically moving this function down to the infrastructure layer with the sidecar, with the proxy, right? So if you have this kind of requirements, which in my experience most banks have, then a service mesh is a great way to start. But then the downside there is that it comes with a hefty, well, it comes with a pretty heavy tax in terms of the added processing. So there is the added latency between when services are calling each other. And then there is also a need for having a team to take care of that stuff, right? So there is some engineering complexity there, and you need a platform team to take care of the service mesh, maintain it, install it, deploy it, and make it easy for your internal developers to actually consume, right? If you're
Yes.
I'm not sure if it was just me, but maybe the last part fell away.
Oh, yeah, I saw that the screen froze for a second. So what I was saying is that if you are looking for a way to like do an MVP or like small startup with 2 engineers that doesn't want to spend too much time on infrastructure, serverless is a great way to start, right? Because you just want to get from code to URL without having to worry too much about provisioning VMs, installing Kubernetes, and deploying a service mesh because it requires engineering time.
Yeah, that's correct. When we are introducing the service mesh, the platform was mature enough to simply move the logic from our microservice SDK to the service mesh, and it was mostly transparent for our users, and they don't have to deal too much with the technical details of the service mesh. But as you said, if you're the small company, probably you shouldn't spend your time working with service mesh. Just use the simplest stuff and get up and running and sell stuff and earn money.
Yeah, because do you see companies running a service mesh without having an actual platform team? I don't think so much, right?
Well, on Google Cloud, we're trying to make that happen by offering managed service mesh. So there is an offering we have on GCP which allows you actually to use Istio service mesh in a managed fashion. So we manage the control plane and we also manage the data plane, the invoice sidecars. So all you have to do is create a GK cluster, put a label on the namespace, and then we will do all the sidecar injection and all the backend stuff. It's possible, but in that case, one of the problems you're going to have is that there will be a lot of functionalities in the service mesh that are offered out of the box you're not going to be able to benefit from because you don't have a platform team to take care of that. So one example that comes, service mesh gives you a lot of metrics out of the box, right? You can collect metrics from the sidecar, and you can, like, it can tell you like the performance or the health of your service. But in order to use those metrics, well, you have to have something to script metrics. You have something to visualize the metrics. You need to build a platform for observability. And if you don't have somebody to take care of that, then you have some good stuff there that you're not kind of taking advantage of, right?
Yeah, nicely said. I think companies should really think about then if they adopt serverless or service mesh, what really fits with their existing teams and also what gives them most value out of the things they're looking for. And in terms of that, there's always the discussion about having a service mesh for your microservices or having an API gateway to handle all requests. What type of companies do you see adopting a API gateway instead of a service mesh? So maybe something you can elaborate on, Abdel?
Yeah. So I want to make it clear that there is actually a clear distinction between what an API gateway does and what it means, and what a service mesh does and what it means. So if we just talk about pure service mesh, if you look at something like Istio, Marcin, are you using? You said you're not using Istio. You're building your own control plane, right?
Yes.
And so how do you handle incoming traffic from outside to the mesh?
Okay, so incoming traffic from outside, most of the time we have AJ proxy deployed as well as balancing solution, and it depends from where the requests are coming, but also we have our edge solution that basically serves as AP gateway, which then translates request to the service mesh and send it via service mesh to other services. So really depends.
That's typically is how most people use service mesh. Is you have a service mesh to handle the service to service communication, and then you have, I think probably you were frozen for a second. So what I was saying is that most of the time when you have a service mesh, you would have your service mesh to do service to service communication, and then you have a way to get traffic inside the service mesh using a set of proxies. In the Istio world, Istio has its own proxies called the Istio ingress gateways. They are very confusing because they are called gateways. They are technically not a gateway. They're just a special proxy that is deployed at the edge of your service mesh to get traffic in, maybe do some JOT token validation, maybe do some authorization before routing the request inside the mesh, right? And those like edge proxies are technically not a gateway, not an API gateway in the pure definition of API gateway as people understand it. An API gateway is typically something that is used for north-south traffic, so outside to inside the system. But the way I like to make clear distinguishing between these two things is an API gateway can do a lot of things that service mesh cannot do. So one example is maybe rate limiting. So beyond authorization and authentication, you could use an API gateway to do rate limiting, right? You could use an API gateway to maybe if your company offers API as a service, you could use an API gateway to do the billing part, right? So to basically charge people for the API calls they're making. And there are certain products that can do that. Um, I have, however, seen cases where people use both. So there is an API gateway, and then there is also service mesh behind it. And the API gateway is exactly used for the purposes I talked about. It's used for a way for people to deploy their APIs, for the rest of the organization to actually kind of discover what other APIs people are available for them, right? So it becomes not only a north-south thing, it becomes like, oh, there is this team in this part of the organization which has an API which we can use to, like, I don't know, read user data or something like that. So the API gateway they're using offers them also like a kind of pretty GUI type situation that the developers can use to discover what APIs exist in the organization, right? And then they do rate limiting and all this stuff. And then once traffic gets in, authenticated and authorized by the API gateway, then it gets into the service mesh where the service mesh checks off the service-to-service communication. But it also, in the case I've seen, the service-to-service communication also carries the JOT token of the user. So the token of the user is actually propagated inside the mesh for traceability reasons, essentially.
Okay. Well, thanks for explaining the two definitions. I think definitely makes sense to think about an API gateway mostly for external traffic, and a service mesh, of course, is also internal. The reason I ask, I also see sometimes companies using the gateway for both internal and external requests. Is that something you would discourage companies to do?
Not really, not necessarily. I have seen use cases where you can deploy an API gateway both internally and externally. At certain companies at certain scale, you will probably want to have an internal API gateway just for the reasons I talked about earlier.
Yes. Okay. And you, Martin, how are you handling these kind of requests internally and externally?
Yeah, so as I was mentioning earlier, so the most of the traffic, internal traffic, is done via the service mesh, and sometimes we are using HA proxy to load balance the requests, and the traffic that is coming from outside of the organization is coming actually mostly via the load balancers, and we have our own API gateway, our server that is doing all of the stuff that were mentioned previously. So for example, billing, rate limiting, and all the stuff. Yeah, so I think that's all. But I more than previously, I see that the people are starting to use some kind of ingress on service mesh as a API gateway. For example, Kuma service mesh. It has its own ingress, and that works basically as API gateway. So I think that's it's also changing, and maybe in the future there will be solutions that solve all the problems, and the need for a separate API gateway will be gone.
Yeah. Okay. Thanks for sharing. And I think also what we want to discuss in this panel, like what is next? What is the next big thing in the service world? Is it maybe decentralized? Is it something else? What kind of new trends or new things are you seeing, Abdel?
Yeah, so I am seeing two major things happening in the service mesh space, at least, and we can talk about servers later. So one of the most exciting things for me is this thing some companies are working on called sidecarless service mesh. So the idea of sidecarless service mesh is to have the service mesh run without sidecars. So why would you want to do that? If somebody asks, Um, a sidecar in a service mesh comes with a pretty heavy footprint sometimes. What I mean by footprint is CPU and memory, right? And more memory than CPU. If you look at something like Envoy, Envoy is developed in C++, is written in C++. So it can process packets fast enough. It does introduce a little bit of latency, but it's not too much. So it doesn't actually delay requests because it has to process a packet. It's pretty fast. But and maybe Marcin, you can second me on this. If you have a service mesh based on Envoy, every single container of the application has a sidecar next to it, right? So basically, if you have 100 containers of your application, you have 200 containers in total. And the sidecar containers need to know how to reach out to every other sidecar. So they have a massive routing table in memory that they have to keep. So those sidecar containers will need a pretty hefty um, amount of memory, right, to run. I don't know if that's the case for you, Marcin. Like, I don't know how large are the clusters you're running.
Okay, so in case of how large are the clusters, so right now we have almost 2000 services that are running inside of our service mesh, but we our envoys don't have to carry all that knowledge, because we only specify few services that we need to communicate. There are special class services, for example, our edge service, load balancers, and our Hermes, which is our event bus, and they have to communicate with all of the services, so they have to be aware of all of the services. But for the rest of services in our infrastructure, they don't need to know where all of the services are. They just need to know where the previously specified dependencies are, and how to communicate with them.
Yeah, so it seems like you have managed to figure out how to make Envoy only carry the routing table for the services they need to reach. But
Yes.
that's not the case with something like Istio or Linkerd, right? With Istio or Linkerd, the default behavior is that every single sidecar in the mesh knows where every other sidecar is and how to reach it, even if it doesn't need to reach it, right? And so this basically comes with a pretty hefty footprint in terms of memory, right? Like the sidecars needs a certain amount of memory to know where all the other sidecars are. So in order to solve this problem, this thing called sidecarless service mesh is actually being worked on. Two companies I know are working on it are Cilium and Solo.io. Solo.io is a service mesh as a service provider. So it's a PaaS platform as a service. And Cilium is a CNI for Kubernetes, but they're also doing stuff around service mesh. And both companies are working on replacing the sidecar with something called eBPF. So eBPF stands for Extended Berkeley Packet Filtering. You can think about it as IP tables plus 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 plus, because it can do more things than IP tables. But essentially, it's a kernel module where you can write plugins to do certain things on traffic, right? And they are moving basically the functionalities that the sidecar does toward eBPF. So instead of having, if you think about it from a Kubernetes perspective, on a specific node, instead of having 10 containers and 10 sidecars, you will only have 10 containers, which are the application, and they will all use eBPF in the node to basically do all the stuff that the sidecar does. Now,
Actually, if
mhm,
I'm correct, this how the Cilium does it. It's a little bit different. They still use Envoy, but the routing between your service and the Envoy is done differently. You don't have to specify the IP tables, go to IP tables, then go to Envoy. It's they're using eBPF to simply transfer traffic from your service to
to the Envoy.
the Envoy, without all of the networking stack that comes in the way. So
Yes,
so that's
yes.
a little bit different.
Yeah, but it's the reason why I was about to mention that. So they are trying to replace IP tables with eBPF, right? For forcing traffic from the service container to the Envoy. And the reason why they need to keep Envoy is because eBPF cannot do everything that Envoy can do, right? So in terms of like they're not like similar in terms of functionalities. But I know that they are working on actually kind of entirely replacing Envoy at some point if they are able to do everything in eBPF. So that's kind of one of the trends I'm seeing, and it's actually pretty exciting. Because one of the things that this is going to enable is basically cloud provider is giving you a fully managed service, right? Since when you go to a cloud provider like AWS or GCP, the node is provisioned by the cloud provider for you. Well, all they have to do is just configure the node special in a special way that forces traffic from the containers to go through eBPF. And since eBPF is part of the operating system, the cloud provider manages that, right? So you just have to create a node, maybe label it to say this is part of service mesh, and then there will be some special programming in the node that forces that traffic to go through the envoy. So this is one thing. The second thing that I am seeing is these conversions between, on one side, serverless platforms across multiple cloud providers. There is now a lot of cloud providers are moving toward containers as a standard format for deploying serverless applications. Um, so it's not anymore like bring your own code, it's bring your own container. So that's one actually exciting thing to look at. And then there are also some cloud providers that are working on bridging the gap between serverless and service mesh by, for example, allowing you to do MTLS from a serverless application toward a service mesh and vice versa, or by allowing you to do like timeouts or retries from your serverless application towards service mesh. So we have it in cloud with Cloud Run and Google Cloud. So Cloud Run is our serverless platform, and today you are able to do MTLS between Cloud Run and the service mesh, right? And that's gonna keep like being developed, and more features will be added in the future.
Nice. Yeah, I think that is a great development, especially the sidecar. Sidecarless makes a lot of sense.
Yeah, but when we are talking about the sidecarless, there is one catch, and which for me makes it a little bit difficult to implement, because the more services you have in the infrastructure, the more configuration there is, and simply it will. I think that it will be hard to manage all of those configuration inside of eBPFs, and it can cause some kind of chaos in some situations. But I think that will be great. For example, if you don't have too much of dependencies and simply want to use service mesh to route your traffic to one or two services. And if they are doing a lot of work and there's a lot of traffic between those services, that it will probably work great.
Yeah, and I agree with you in the sense that the challenge with moving everything to a central envoy is that central envoy now have to handle traffic for all the services behind it on that specific node. So there will be a challenge of how do you scale it up, right?
Yeah.
Like instead of having one service, one sidecar, where the sidecar only have to handle traffic for that specific service, when now you have a single envoy in the node that have to handle traffic for everybody. And so you have to, I don't know what's the future there, maybe building some sort of quality of service where you can prioritize traffic based on, which containers are more important for your service. And I know that Envoy can scale horizontally very well. I'm not sure if it can scale vertically, right? So that's these are kind of the challenges that have to be overcome actually for the sidecarless service mesh.
Yeah, actually, as for the vertical scaling of Envoy, I think it's nice. The way the Envoy was designed and implemented, it was in a really scalable way, and most of the code is reactive, so it doesn't block on logs in the classic way. And they are really efficient in using additional threads in your system. So the more resources you give to Envoy, the better it will work. So I think that won't be the problem. The main problem here will be how to configure this and how to manage this configuration.
Yeah, it makes sense. I can imagine for a lot of different services, it can get complicated at some point. So what are some trends you're seeing, Martin, besides sidecarless, either personally or within your company?
Okay, so as for the service mesh, beside the sidecarless thing, the one thing that is interesting for me is adding more custom functionality to the proxy, to the Envoy, because you can do it in a few ways. You can implement your own sidecar that can be deployed alongside with Envoy, and you can send requests from Envoy to that sidecar that is already implemented in Envoy, and it works. It works nice. So I see some companies that were doing custom metrics on Envoy using that kind of mechanism, and for example, there are many other things, ways how to extend the Envoy capabilities. There is this project, Open Policy Agent, which gives you its own declarative language and works really nice with Envoy, and you can extend the logic there. The interesting thing that is going on is the Hazelcast project Turbine, which gives you support for not only classic service mesh stuff like communication between services, but they are also trying to move the logic of distributed workflows to the sidecar. For example, you can use Saga pattern when dealing with distributed transactions via their sidecar. And for example, they give you the interesting thing is give you the API, for example, for dealing with Kafka. You don't have to implement your own logic around Kafka, how to subscribe, how to pull new messages. The sidecar can do it, and the sidecar will send you the classic HTTP requests with new events from the Kafka. So that's the interesting way when things are going for me.
Sounds really cool. Could you repeat the name of the project or use the chat to paste the link for the audience?
Okay, it was Hazelcast Turbine.
Okay, thanks. Sounds really cool. If you can use the chat, then people can check it out themselves. I see we have a couple more minutes. Anything you want to share with the audience still, Abdel?
There are actually a bunch of articles. Just Google search serverless sidecar service mesh or sidecarless service mesh. You'll find quite a lot of articles discussing this topic. There are a couple of also third-party articles that are by people just analyzing more about service mesh specifically with Istio. There are two books I could recommend: Istio Up and Running and Service Mesh with Istio. You can Google search them. They're pretty good books to kind of get started. And yeah, follow me on Twitter. I do post about these things all the time. Shameless plug.
Okay, great. Thanks for sharing the link to the Hazelcast Turbine. Anything you still want to share with the audience, Martin? Or a Twitter account? People can follow you.
I don't have Twitter, or maybe I have, but I don't use it regularly. I don't think I just want to encourage people to go look, read more about the service mesh serverless, and get curious about how those solution works. There was really a lot of really hard and interesting engineering stuff inside of those projects. So you can go and look at Istio and other service meshes and how Envoy is implemented, and try to understand those stuff, because for me it's really nice.
Okay. Well, thanks for sharing, and thanks everyone for watching. I see Abdel posted his Twitter link in the chat, so make sure to follow him to learn more about Service Mesh. And well, thanks everyone for joining. And as Martin said, make sure to, or at least I hope people feel encouraged now to read more into the topics we discussed. And also people will enjoy the rest of the conference. So thanks to Abdel and Martin, and thanks everyone for watching. Bye-bye.
Bye.